Yo, what's up, everyone? Oh shit, we're already live. Okay. We're just waiting for the announcement to go out, and then we will start. How you guys doing? I missed you. Did you miss me? I missed you. I love you. Ugh. Eh, Damn, it went live way too quickly. um, there we go. Announcement's going out, and we good. Let's get back into this shit. For GUIs, um, I'm gonna be honest, dude. I'm not a fucking front end dev, so I don't know. I know you can use Pygame. Pygame's pretty good. I'm sure there's other ones out there
Asking. You can use
though.
the care.
Oh, by the way, this will be black right here. You guys won't be able to see it, most likely. So, I'm just gonna leave it that way because, I don't want to get sued. So, we're gonna go ahead and keep it that way. Let me make sure everything's set up and working. Give me a second. Oh shit. So you can see it. That's interesting.
Method to retrieve an iterator that you can use to iterate through the Unicode scalars. And
Okay, where
finally,
are
you can
we?
use a package like
Hold on. What the fuck are we talking about? Oh, the bytes. Okay.
Unicode segmentation, which provides handy functions for return iterators that handle graphemes of various types. With each of the
I think. Well, I just updated Firefox, so I think the DRM went out. It looks like DRM isn't on here
these
anymore.
approaches, you know that if you can index into something, it will
But yeah, if it if it goes out, just know I'm not gonna fix it. Sorry, but I don't want to get sued. So you guys need to buy it just like I did. Okay? I love you. I'm sorry.
be a fast, constant time operation, while if you iterate through something, it is going to process some variable number of bytes during each iteration of the loop. Hopefully, you can sidestep most of these issues by using one of the many helper methods created
Oh
to
my
manipulate
god, there's
strings.
so
But
many.
if you do end up manually using one of the iterators have a handy method called nth that you can use in place of indexing. And now you know why you have to pick an iterator and use nth instead of being able to index into a string directly. In the next
Okay,
video,
so
we will
hang
talk.
on. So I have to do. Hang on one second. So I have to do. Um. Fine. What was it? Nth? Is that what he said? The nth? Message to the nth 3? Okay. Yeah. So, and chat already bought it, right, guys? Yeah, they already bought all of it, so it's fine. No expression inside bracket. Okay, I can't put expressions. Nchar equals message to nth 3. So then nchar. No, method not found in and string. Whatever.
Being
I don't
able
give a
to
fuck.
index into a string directly. In the next video, we will talk about ownership.
Ownership. You guys ready for ownership? Exercise D.
It's time.
It's time for that D. Okay, sorry. Um, yeah, it's pretty old, but still, man, it's working. It's fine. I'm learning. So exercise D. Source main. Alright. Vector, for example, carve around apple produces the equivalent of vec. Args consumes the args to iterate through each arg. Your task: handle the command line arguments. If arg is sum, then call the sum function. Okay. if arg equals sum else if arg equals double or is anything else count arg, right? Okay. One, two, three. Oh fuck! What am I doing? Hang on. CD exercise CD ultimate exercises D cargo run sum. The sum is 0. Okay, cargo run. Yeah, okay, cargo run double. Okay. Nth is probably going, yeah, probably. Cares.nth. I'll check here in a second. Let me finish this up real quick. Now try passing sun double bananas to the program by adding your arguments. Bananas? What the fuck? Oh, got it. Yeah, never mind. Okay. Use a for loop to iterate through the integers from 7 to 23, inclusive, using a range. And then add them all together. Let more sum all sum for 7, 23, all sum plus equals I. Oh, yeah, okay. That should work. Sum, nope. Maybe it's. Where's the original fucking one? This one, right? Nope. That's not the one I was just on. Okay. I have it written down somewhere. Hang on a second. For X and yeah, okay. I don't need the brackets. Yeah, okay. Yeah. I don't need the brackets. You're right. I got it. Okay. Use a while loop to count how many times you can double the value of x. Multiply x by 2 until x is larger than 500. Increment count each time through the loop. Run it with cargo run double. Okay. While count less than is which one? Okay. Less than 500. Multiply x by 2. X. Can I use times equals? Is that possible? We're about to find out. Oh fuck. Oh fuck. Yeah. Okay. Always remember less than is left. Oh, that's good. Dude, I Google it all the fucking time. I'm retarded as shit, so don't judge me. Count. Use a while loop to count how many times you can double the value of x. Well, count is less than 500 until x is larger than 500. Okay, let's do that. Should be 9. Didn't exit successfully. Display a backtrace. Run the rest backtrace. Oh my fucking god. Attempt to add with overflow? What the fuck? Okay, let's do x equals x plus x. Let's try that. Nope. Okay. Less than 5. Well, oh shit. Well, x. Got it. There we go. Not bad. Figured it out. Okay. That worked. We're good. Okay. Use an unconditional loop to print arg 8 times and then break. You'll need to count your loops somehow. What count equals 0. Loop. Print line. Or if count is less than greater than or equal to how many times? 8. Break. Break. Loop. Loop. Count plus equals 1. Print line. Line. Should be 8 times, right? Oh, no. Okay. Let's put this in here. I don't need a double. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Cool. Okay. Yep, 500 to overflow. That's not very many, right? I'll put a new line. Okay, so that's done. Finish that. That was fucking easy. Next.
For exercise D, control flow and
Fucker control flows.
and last
Pussy.
there's the challenge.
Here, let's see if I did it right, actually.
Control flow and string.
Can you guys still see that? I think the overflow is probably recursion limit. That would make sense. So they put a recursion limit of 500 and then just
Once again, I
let you
encourage
fuck with
to
it.
try this exercise
You don't
by
see it?
yourself.
Oh man.
Pause the
Alright.
video and then come back when you're done if you want to see how I did it
Let's
or if
see.
you need help. Alright, now that you've had a chance to do this
Yeah,
exercise
you can't see this
yourself,
one. Sorry,
let's
guys.
run through it.
Alright, we're gonna run
This
through this
command
though.
collects any command line arguments into a vector of strings. Then we're going to iterate through those arguments and do some things with it. 1a. Handle the command line arguments. First, if the argument is sum, then call the sum function. If the
Okay.
argument is double, then call the double function.
Thanks.
If the argument is anything else, then call the count function, call the sum function.
If arg sum, yep, that's
Else,
right.
if arg is double,
Yep, that's
then
right.
call the double function.
Oh my gosh.
Otherwise, call the count function and pass arg to it.
Okay.
1b. Now try passing sum, double, and bananas to the program by adding your argument after cargo.
Oh, I'm supposed to pass,
For example,
okay.
cargo run sum.
My bad, hang on. Let's pass bananas to this bitch real quick. Make sure it actually does what it's supposed to do. Yeah, okay, we're good.
So how do we pass our own program?
Yeah, you can't see it right now. Sorry, everybody.
Cargo might try to intercept
Say
it.
blah 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 blah.
Okay, you can double x 0 times. I'm sure we're going to be changing that. Next.
What the fuck is that? Why do you do this? What does that do? Hold on. Let me go back.
Dash dash like this.
Why?
After the dash dash, Cargo might try to intercept it and treat it as its own argument. To prevent that, we add a dash dash like this. After the dash dash, anything will be passed to your program and ignored by Cargo.
What the fuck? Why doesn't it just know what to pass? I guess that makes sense.
0. Let's try double.
That's fine. Let's go.
For loop to iterate through integers from 7 to 23 inclusive using a range and add them all together. Increment the sum variable. Hint, you should get 255. Then run it with cargo run sum. For I in 7 to 23. Now, if we did it like this, that would be exclusive. So we'd need to go 7 through 24. Or we could do 7 through 23 with a dot dot equals. So let's do that.
Okay. Already
and
done.
then we'll take sum and add I to it. Now this is just
this is exactly what he did.
Sum equals sum plus I.
This
exactly the same thing.
Exactly right.
That's
God,
all
I'm
we
fucking
should
good.
need to do here. That will iterate through the numbers 7 through 23 inclusive and add them to sum and then print them out. Let's give
dust
it a
my
try.
Tims off, G. Cargo run sum. Okay. Cargo run sum. Sum is 125.
255.
255.
Number 3.
No,
Use
125.
a while loop to count how many times you can double the value of x before it is larger than 500. Increment count each time through the loop. Run it with cargo run double. Hint, the answer, well, x needs to be larger than 500 when we quit. So x is smaller than 500 while we're going. So while x is smaller than 500, what do we need to do? Well, we need to increment count. So count, and we need to double x. X times equals 2. All right, that should do it.
He did times equals, but that doesn't make sense because fucking 1 is 1. This will loop for fucking ever.
Do it for that. So let's save and go give it a try. Cargo run double. You can double x 9 times.
What the fuck? Hang on. Yeah, this shit's gonna loop forever. What the fuck? Am I stupid? Like, because I know this works, and it works well, and it gets the same fucking answer that he has, which is 9. But he does times equals in here. Times equals 2. Okay. I got it.
That. So let's save and go give it a try.
Okay, I'm
Cargo
stupid.
run
The answer is I'm stupid.
You can
Yeah.
9 times.
Okay, next.
Let's talk about ownership. Ownership is
Okay, let's start ownership. Yeah, I'm just stupid. Don't listen to me. I'm horrible at math. Like, I'm really, really bad at it.
Why I chose to learn.
Which is interesting because my youngest son is like incredible at math. Like, he's 10 and he does like fucking calculus and shit. It's crazy, but I'm awful at it, so I can't help him on anything.
in the first place.
And then my oldest son is he's horrible at math like I am, so.
A few years ago, I decided I really wanted to master a systems programming language. I don't know about you, but I don't have a lot of extra time in my day. So if I was going to master a systems programming language, I wanted to make sure it would be worth it. I spent a month researching all the options, and it really came down to 3 viable choices in the end. C or C++, both of which I had already had painful experiences with, or an up-and-coming new language called Rust. Rust's ownership model is the reason that I chose.
Sometimes I fumble around. I don't remember the operators correctly, so I have like a weird autism or some shit, and I can't remember like less than and greater than multiplication. It's hard for me to remember the
To spend my
operators.
extra time focusing on Rust. Ownership is what makes those crazy safety guarantees possible and makes Rust so different from other systems programming languages.
Hmm.
Ownership is what makes all those informative compiler error messages possible and necessary. There are 3 rules to ownership.
Okay.
First, each value has an owner. There is no value in memory, no data, that doesn't have a variable that owns it. Second, there is only one owner of a value. No variables may share ownership.
Isn't that the same as like any other fucking programming language? Technically?
Other variables may borrow the value, which we'll talk about in just a minute, but only one variable owns it. Third, when the owner goes out of scope, the value gets dropped immediately. Let's see ownership in action. Let's create a string s1 and then create another variable s2.
Okay. Equals string from ABC. It's fine. One. Okay.
And assign s1's value to it. What happens to this string is not a copy. At this point, the value for s1 is moved to s2 because only one variable can own the value. If we try to go ahead and use s1 after this point,
This is if this is intentional, prefix it with an underscore. Ownership. Generated one warning.
we get a compiler error.
Hold on,
Borrow
hold
of
on, hold on,
moved
hold on.
value
Hold on, hold on, hold on, hold on.
If we
Okay.
try to go ahead and use s1 after this point, we get a compiler error.
Okay.
Borrow of moved value s1. So what's going on here? Well, we've got stack and heap sections of memory, just a
So I could just clone this and it'll do the same shit? Okay. Yeah. I get it. This is where the fun begins.
super quick refresher. The stack stores values in order, which it can do because values are always fixed size. And the last value in is the first value out, which all tends to be very fast because it's so compact and predictable. The heap, in contrast, stores values all over the place. And values tend to be all sorts of sizes and don't get dropped in any order that corresponds to when they were created, which tends to make using the heap slower than the stack because you're always hopping around memory, flushing and reloading your CPU's memory cache. What does that have to do with a value being moved? Let's walk through it.
Okay.
First, we create S1, a pointer.
Can you guys see this or should I write
A
it down?
length and a capacity get pushed onto the stack.
Okay. S1. Pointer when yeah. Okay.
The value of capacity in this case is 3. The length
Stack.
is 3, and the pointer points to some newly allocated bytes on the
Heap. A, B, C. Okay.
heap. This altogether is the value of the string S1. Then we move S1's value to S2 because we can only have one owner. It works like this. The pointer length and capacity all get copied from S1 and pushed as new values on the stack as part of S2.
That's
If we
why
stopped
clone
here,
works.
then memory safety would be non-existent, which
I
is
get
why
it.
Rust immediately
Yeah,
invalidates
yeah, I
S1.
get it.
It
Okay.
still exists on the stack. The compiler just
So
considers
if I did
S1
this
now
and went like
uninitialized and won't
this,
let you use it after this point. It's
theoretically
more
this
than
should
a
still
shallow
run.
copy, it's
Yeah,
a move.
I get it. Okay.
Which is why we can't use S1
Okay.
anymore. The value has moved to S2. Technically, if S1 were mutable, we could assign it some new value and then use it again. But since it is immutable in this example, it's just garbage and we can't use it
So if
anymore.
I
What if we didn't want to move the value,
went like
but copy it
this,
instead? To make a copy of S1, we would call the clone method. Why is it called clone instead of copy? Let me explain what it does under the hood, and then I'll tell you. Clone performs the same initial copy of the stack, but then also copies the heap data and adjusts S2's pointer to point to it. In both the move and the clone situations, the three
I get
rules
it.
are satisfied.
Yeah.
1. The values have owners. And 2. Only one owner. And 3. When the variables go out of scope, the values will be immediately dropped. The stack and heap data, if there is heap data, together make a value. Rust reserves the term copy for when only stack data is being copied. If there is heap data and pointer updates involved, then we use the term clone. In other languages, you might call a clone a deep copy. When a value is dropped, that means the destructor, if there is one, is immediately run. The heap portion is immediately freed, and the stack portion is immediately popped. So, no leaks, no dangling pointers. Yes, happy programmer.
Wow.
Another move situation. Let's start with the same string and make a function that takes a string and returns nothing.
Okay. So let's make the function first. Function do stuff s string print line. Let's just s. There we go. Now it doesn't really fucking do anything. Perfect. Okay.
If we pass s1 to that function,
Let's pass s1 to that. Stuff s1. It should work, right? Yeah.
s1 is moved into the local variable s in doStuff, which means we can't use s1 anymore because it got moved. So what do? One option is to move it back when we're done. We'll just make s1 mutable, add a return type to doStuff, and then return s as
So then I would do s equals that. S1 equals that. Print line S1, right? No. No, no, no.
the tail expression, which gets moved back out of the function and used to reinitialize s1. But that's usually not the pattern that you want. Passing ownership of a value to a function usually means a function is going to consume the passed-in value. For most other cases, you should use references, which is why it's time to talk about references
Oh my god.
and borrowing.
This is about to be a nightmare, isn't it? Okay, so before I start this part, how big of a fucking nightmare are references? Are they awful? Is it like pointers? Okay. Okay.
Now that we've gone over ownership, we can talk about references and borrowing.
A pointer
Instead
that
of
cannot
moving
be
our
null.
variable, let's
Okay.
use a reference.
Okay, let's use a reference. Sounds like a plan, sir. Let's do that. Okay. So let s1 string from ABC. Okay. So that's what we started with.
Here's our doStuff function again, only
We're gonna fix the do stuff function. Do stuff s and string, which is fine. Makes sense. Do stuff. Okay.
this time it takes a reference to a string. The ampersand before the type indicates a reference to a type. When we call doStuff, we pass it a reference to s1.
So it's basically just a fucking pointer. So if I did this, do stuff, and s1. If I went print line S1. This will work because I'm giving it the reference to the pointer. No? Oh, S. Yeah, see? Boom, perfect. No errors,
And
no warnings.
S1
Okay.
retains ownership of the value. DoStuff borrows a reference to the value. The reference, not the value, gets moved into the function. At the end of the function, the reference goes out of scope and the reference gets dropped, so our borrowing ends at that point. After the function call, we can use S1 like normal because the value never moved.
And then print line outside of DoStuff function. And this should work perfectly. Okay. inside of DoStuff function. Yeah. Function with reference without reference. Right? Yeah, okay.
Under the hood,
Hang on, my wife's texting me. Definitely. It's my wife's birthday, so
when we create a reference
she's
to
at TJ
S1,
Maxx.
Rust creates a pointer to S1. But you will almost never talk about pointers in Rust because the language automatically handles their creation and destruction for the most part, and makes sure they're always valid using a concept called lifetimes. Lifetimes can be summed up as a rule that
I'll tell her you guys said happy birthday. Everyone on stream says happy birthday, Miss Malcor, Mrs. Malcor.
Must always be valid, which means the compiler won't let you create a reference that outlives the data it is ultimately referencing, and you can never point to null.
Okay, but why can't I
References
point to null? Isn't pointing to null useful? Like, can't I point to null if I want to?
Default to immutable, even if the value being referenced is mutable. But if we make a mutable reference to a mutable value, then we can use the reference to change the value as well.
S and mut string. So then I could do s dot insert string 0 1 2 3, and that should do stuff and mut, right? Okay, and then it will just change the entire string. Got it.
The
Okay.
syntax for a mutable reference is a little special. Ampersand mute space variable or type.
Okay, I got it. You can call raw pointers, at least some cool things that happen with the reference cannot be null. Okay.
Now wait, why didn't we have to dereference the mutable reference in order to alter s in the doStuff method? Look at this.
She says
We are
thank
using
you.
the same dot syntax to access a string method on a mutable reference as we do for the value itself. How does that work? The dot operator for a method or a field auto dereferences down to the actual.
Okay, so you can type called option T, which is a tag known as neither none or some T, since the reference cannot be null. If you have option T, does niche optimization, uses null as a none tag, and anything else summon T. Cool. Okay.
Value.
Okay.
So,
Gotcha,
at
gotcha.
least when you're dealing with the dot operator, you don't have to worry about whether something is a value or a reference or even a reference of a reference. If we manually dereferenced s, it would look like this. You use an asterisk immediately.
So dereference S. What the fuck does that mean? Star.
Immediately before a reference to dereference to the value, similar to C. The dereference operator has pretty low precedence, so you'll sometimes need to use parentheses. With most other operators, like the assignment operator for example, you will need to manually dereference your reference if you want to read from or write to the actual value.
Okay, okay. Hold on. Let's go back to this shit real quick. So S dot insert 0 high star S equals string from replacement.
Here I'm dereferencing s so that I can replace the entire value. So let's stop and go over what references look like again. If you have a variable
Line S and string. Oh, I did that wrong. Insert string. That's cool as shit. Okay.
Here I'm
If you
dereferencing s
reference
so
to
that I can
something, hang on. Also, this way, if you reference to something, you don't need to check for null. That's fair. Yeah, that's fair.
replace the entire value. So let's stop and go over what references look like again. If you have a variable x, then this creates an immutable reference to that variable's value, and this creates a mutable reference to that variable's value.
Okay, so if I have var x, I can make immutable by just doing x. Hang on. Immutable by just doing and x. And mutable by doing and mut x. Right? Yeah.
Value. Similarly with types, if this is the type of your value, then this is the type of your immutable reference, and this.
So I can do it with types too. So I can do I32 and I32 for immutable and mut I32 for mutable. Oh my god.
Is the type of your mutable reference. Going the other way around, if your variable is a mutable reference to a value, then dereferencing x gives you mutable access to the value.
Okay, that's fine.
And if x is an immutable reference to a value, then dereferencing x gives you immutable access to the value.
Alright, so let's do x and 32 star x. So then this one would be x and mut I32 star x, right?
To the value. And if x is
Yes.
an
Okay.
immutable reference to a value, then dereferencing x gives you immutable access
That's
to the
fine.
value.
That's fine.
Naturally, since references are implemented.
Okay. Let's do immutable. Okay. Got it.
Via pointers, Rust has a special rule to keep us safe. At any given time, you can have either exactly one mutable reference or any number of immutable references. This rule applies across all threads. When you consider that references to a variable may exist in different threads, it starts to make it pretty obvious why it's not safe to have multiple mutable references to the same variable at the same time.
Okay, but what if you have to? Like, let's say I can make a function right now. Let's say I have my x equal 123, and I have to fucking add and then subtract and then fucking multiply all in a different thread. What if I have to have that reference
without some type
multiple
of locking.
places?
But if all the
So that would mean that I can't do.
references are
Never mind.
immutable, then there's no problem. So you can have lots of immutable references spread across multiple threads. All these rules I've been talking about are enforced by the compiler. And by enforced, I mean compiler errors. Lots of compiler errors. At first, you're like, I hate the compiler. It keeps giving me errors. But then as you get the hang of it, you realize you don't get mysterious seg faults anymore. And the error messages are really pretty informative. And if the code compiles, it works.
Let's see. Let's do S3. I want to see how. A local variable with similar name exists, S3. That's cool. Okay. I like that. So then, local variable with similar name exists, S3. That's fucking. Okay. I do like that. I do like that. That's really nice. Compiler's pretty good. Okay, I'll give you that.
And
The
that
compiler's
is an
pretty nice.
amazing feeling. In the next video, we'll learn about structs.
Structs. Yay. Structs. Here we go.
Exercise
Exercise E. Okay, let's get to it. Ultimate exercise E. Alright, ultimate exercises E. Source main.rest. Okay, let's get through this. Fancy stuff either gets the first argument of a string or prints usage and exits if an argument was not supplied. Okay, cargo run. Should. Process didn't exit successfully. Please supply an argument. Okay. Write a function, inspect, that takes a reference to a string. Returns nothing, but prints whether the contents is plural or singular. Then uncomment and run this code with cargo run apple, cargo run apples. Inspect. Okay, so let's do function inspect and s string arg string, and then but prints whether the contents of the string is plural. If do I just do arg ends with s on, I think string is plural. Else string is singular. That should do it, I think. Cargo run apples. Yeah, that didn't do it. Inspect. Let me go back real quick. That's right. It's and there we go. Arg dot ends with s. There we go. Okay, cool. Okay, that one's good. Write a function change that takes a mutable reference to a string and adds an s to the string if it doesn't already end with s. And uncomment and run the code below. Change. Okay. So function change arg string and not string, right? Yeah. If not string that ends with s. How did I do that last time? String dot insert. Can I do string? Can I plus equal on strings? I don't know if I can do that or not. Okay, this compiler is pretty nice. Okay, okay, I get it. Okay. Write a function eat that accepts ownership of, consumes a string and returns a bool indicating whether or not the string both starts with a B and contains an A. And operator. Here, let's split that right. So write a function eat accepts ownership of a string. Wait, no. What the fuck do you mean accepts ownership of the string? Write a function e that accepts ownership of a string. So arg turns a bool indicating whether or not a string both starts if starts with B A. Right? No, that's not right. Yeah, that's not right. And oh, it wants me to do it. And arg contains that contains what? A. Okay. Okay, so dead code, that's fine. So that should work. Expected bool. Mismatch type. Alright, I'm just gonna
E.
watch this real quick.
Ownership and references.
So,
Once again, I encourage you to try to do this exercise by yourself and then come back.
that's fine. So, mismatch types. If args are not arg things. Mismatch types if each arg. Can I just do that? No. That's mismatch types. So if each arg. Can I do this? I don't think so. No.
All right,
Okay.
now that you've had a chance to do this
Let's
yourself,
get to
let's
the
run through it.
third
This
one real
code
quick.
either gets the first argument as a string or prints usage and exits if an
Okay.
argument wasn't provided.
Let's skip that one for a second. We'll just skip over this shit real quick. And we'll continue what we're doing. And then try runs from boat, banana, grapes as the arguments. Bedazzle takes a mutable reference to a string and ignores dereference, immutable reference, or assign it. Okay, fuck it.
Next,
I got
we've
2 out
got
of 3.
our
We're good.
function inspect that takes a reference to a string,
Yeah, I got a.
returns nothing, but prints whether the contents of the string is plural or singular. So the point of this function is to take a reference to a string so that we can look at the string and then print something out. I'm going to go ahead and make this function right here in line. This is bad style. Don't do this in real life. We'll move it down to the bottom later. Our function is named inspect and it takes a reference to a string. I'll just call that s. The function doesn't return anything, so we can go straight to the function body. We know we're going to print something, so let's add a print line. Let's make this one the plural print line, and then we'll copy it and change it to singular. For those to work, we need to pass our string reference s to both print lines. The point of the function is to print out either one or the other. So let's add our if statement and check to see if s ends with s. If it does, then let's print out that it's plural. If it doesn't, we'll print out that it's singular. So
Okay,
our
so I'm right.
inspect method
Yeah, this is
takes
right.
s, which is
That's
a reference
fine.
to a string. It then calls s.ends with. The dot dereferences down to the value and calls the ends with method on the value. We pass it a borrowed string slice s, and then if it does end with s, we print out it's plural. Otherwise, we print out it's singular. Let's give it a try. If we do cargo run apple, we should see apple is singular. Great. If we add an s, then we'll see apples is plural. Now I'm going to clean up after myself real quick by putting this function down outside of main. Now let's do number 2. I'm going to uncomment this code, and then we'll write a function that takes a mutable reference to a string. The function's called change. I'll call the argument s again. Our task this time is to add an s to the end of the word if it doesn't already have it. This is going to begin really similarly to our last function. We're going to use s ends with s, only this time we care about if it doesn't end with s. If it doesn't, then we'll use the push stir method to add an s to the string. This only
he didn't use plus equals like I did. He used string. I don't think I'm supposed to do this either. String dot push string s, like that. And he didn't put the fucking star there either.
only works if we have a mutable string, and we have a mutable reference to a mutable string, so this will work. Now that I have this written, let's move it down to the bottom of the file where it ought to go. Let's go try it out with cargo run apples. There's our new output. In this case, we passed in apples and
Yeah,
it came through
so
unchanged.
he did it this way instead, which is pretty fucking ugly if you ask me, but it works. So I like this way more, to be honest with you.
If
This
I
looks better
pass
than
in
this.
just apple, we can see that our function
Why
adds
the
an
fuck are you
S.
writing Rust? So you see it. I bought 6 Rust courses, and I am. That star is not used. It doesn't fucking matter. Shut the fuck up. So I bought 6 Rust courses, and I'm just gonna learn Rust. So that's
Awesome.
what we're streaming for the
Still
next
turns
like
out the
year.
same thing.
You're welcome for
All
my
right, let's go back
presents.
and do number 3. First, let's uncomment this code, and then we'll make
Okay,
up
this is
this
the
new
one I don't
code,
fucking
eat.
understand.
Eat is going to take a string
Okay, hang on. Let me fucking uncomment
by
that real
value,
quick.
which means it's going to consume it. That means that the variable passed into this function won't be usable
Where
anymore
are the socks? You know how many people have fucking asked me about the programmer socks, dude? Like, goddamn.
after the function call. This function returns a boolean. To determine
Oh, I'm fucking stupid. Yeah, I got it. Okay. Angry Paw. Is that really a fucking website? Angrypaws.com? There's no fucking way that's a website. Absolutely not. Absolutely fucking not. Hang on. Oh my god, it's real. You fucking degenerate ass motherfuckers. Look at this shit. Look at this degenerate ass shit. These are $18 socks? What the fuck? You mean I can sell programming socks and you motherfuckers will buy them for $18? Holy shit. You degenerate ass pieces of shit. All of you. What the fuck? There's no way. Arm warmers? What the fuck? Oh. You'll buy Malcore programming socks? Done. Fucking done, bro.
the return value, we need to figure out if this string
Okay.
starts with
Yeah,
a
so
bool and
I forgot the bool. So if I pass this shit fucking bananas, I don't remember how to spell bananas. Hang on. It'll work. Boom. Might be bananas. Yep. Oh shit. I have mini bullshit. Okay. Boat, banana, and grapes as the argument. Grapes? Grapes. String is plural. I have many grapes, not bananas. Boat. I have many boats. Might be bananas. Oh. All I gotta do is fucking and r dot contains n, and that'll fix that issue. Jenny. I have to dip, still work on it, bro. Alright, bro. Talk to you later. Have a good one. Good luck at work. And write a function bedazzle that takes a mutable reference to a string and ignores what is in the string and replaces the contents of the string. String sparkly. Function bedazzle. Dazzle and my string. Okay. Then replace it. Yeah, okay. So percent %s equals string from sparkly. Sparkly. Oops. And then that should fix that. Correct? Yeah. Boom. Got it.
Contain.
Yep, okay. Next.
It's time
Next.
to learn about struct.
Thank you, next. Alright, let's learn about structs. Cargo run structs. Oops, cargo new structs. Okay. Let's go to structs. Boom. I get it. Alright. There we go.
In other languages, you have classes. In Rust, you have structs. Structs can have data fields, methods, and associated functions. The syntax for the struct and its fields is the keyword struct, then the name of the struct in capital camel.
Okay, so it would be struct red fox is what he's using, so that's what you'll use. Enemy bool life u8. Got it.
Case, red
Again.
fox in this case,
Okay.
then curly braces, and then the fields and their type annotations in a list.
And then can I access what's in the struct with red fox dot enemy equals false? Can I do that? Print line red fox fox. Can I do that? Will that work? Let's find out. Nope. Literal syntax instead, red fox. Can't print a red fox. Okay, that's fine. Help the path separately refer to an item. Oh, my bad. There we go. No. Not found? What do you mean it's not found? It's right fucking there.
Separated by commas.
So
And
I'm
as
wrong.
a nice touch, you can end your last field with a comma as well, so the compiler doesn't yell at you when you add another field and don't think to add a comma to the field before it. This feature is repeated in lots of Rust constructs that use commas. Instantiating a struct is straightforward, though verbose. You need to specify a value for every single field. Typically, you would implement an associated function to use as a constructor to create a struct with default values.
Okay. So I do function new fox self self fox enemy true life 70.
And then call that. Method.
And then I can call the new fox method or function, right? Not allowed in a function. Implement red fox. So it'd be implement red fox. And then I do red fox, new fox, right? Undeclared type. No.
And associated functions are defined in an implementation block that is separate from the struct definition.
Function new. Here, let's do it that way.
The
Self.
implementation block starts with impl, and then the name of the struct whose functions and methods you are going to implement.
Okay.
This is an associated function because it doesn't have a form of self as its first parameter. In many other languages, you would call this a class method. Associated functions are often used like constructors in other languages, with new being the conventional name to use when you want to create a new struct with default values. You'll note that self with a capital S can be used in place of the struct name inside the implementation block. You can also just type out the struct name if you want to, but I recommend using self instead. Let's create our red fox like this.
Let fox equal fox new. Not in this scope. What the fuck do you mean not in this scope?
The scope operator in Rust is double colons, and we use it to access parts of namespace-like things. We've already used the scope operator in use statements to access items inside of modules. Here we're using it to access an associated function of a struct.
This is what he's saying to do.
Once you have an instantiated value,
Let fox equal red fox new. Yes. So implement struct. We're all good here. That's what he put, right? Yes. So implement red fox function new self. Self enemy true life 70. Okay. So then
access parts of namespace-like things. We've already used the scope operator in use statements to access items inside of modules. Here we're using it to access an associated function of a struct. Once you have an instantiated value,
so
you get
he says I can do let life left equal fox dot life fox dot enemy equals false. He says that I can do this shit, but I can't. So cannot find red fox in this scope. What do you mean you can't find it? It's right fucking there.
set fields and call methods with dot syntax as you do in most languages. Methods are also defined in the implementation block. Methods always take some form of self as their first argument. At this,
Can you do that inside of a main function? I have absolutely no idea. Let's try taking it out of the function. I mean, did the same fucking thing, so can I do function create fox struct definition? Hang on.
point in the tutorial, for
Let's
most
just
other languages,
let
I
him
would
keep
go
going a
for
little bit.
class inheritance for a little bit, or struct inheritance, since that's what Rust calls its classes. It's a short discussion though, because there is no struct inheritance. So wait, is Rust an object-oriented language or not? Well, it turns out that's a religious war question.
Oh, you don't have a struct def for red fox? He didn't go over that. What's a struct def?
Because there's no universally accepted definition of what an object-oriented language is or isn't. And since the Rust community doesn't do religious wars, nobody really cares what the answer is. The real question is, why doesn't Rust have struct inheritance? The answer is because they chose a better way to solve the problem we wish inheritance solved.
Traits, which is what we are going to talk about in the next video.
Okay, that's cool, but your fucking code didn't work, so what am I supposed to do? Struct. Yeah, I have that right here. But I used it as a function, so I can call function. Can I not use it as a function? Hang on. I got you, but what you just said didn't work. Struct red fox still doesn't do anything. So hang on, let me fucking Google this shit. struct value and self index is self.value. Okay. Yeah, right here, I can do that. That's allowed. So, hang on. So I can do this. Confusion struct and self trait. See, self is for when you have an instance of the thing, see how above. You just need to make a separate definition for struct. So struct player. Oh, gotcha. Okay, so I need struct red fox, fox enemy bool life u8, and then generator one warning. Let my fox. If this is intentional, fox at enemy, print line, life left is enemy, fox enemy. Can I do that? No. Okay. I get it. Yeah. Okay. Sounds good. Sounds good. Why the fuck didn't you go over that shit then? So you have to make the struct, and then you can implement the struct and implement functions into it. Like I could do a function. Let's do fox color string, and I can do new red fox color string from red. And I could do new, maybe, right? Self. Here, let's see it. I don't know if this will work or not. Let's find out. Enemy false life 50 50 color string from black. Fox new. Then let mat equal fox new black fox. then we can fucking print. Okay. Let's see. Maybe. Hang on. Function associated not found in Fox. Implement. Oh. Okay. Yeah. I get it. Okay. Sounds good.
Traits.
Okay.
Traits are similar to interfaces in other languages, and they're really cool.
Traits. Cool. Cargo. New traits. CD. Rest. Traits. Okay. I get it. I get it. I get it. I get it. Cool.
Rust takes the composition over inheritance approach. Remember our red fox struct? Let's make a trait called noisy. Traits define required behavior.
So, traits. So he wants to do struct red fox again. Red fox. Enemy bool. Life you 32 this time. Okay. Getting a little crazy. Noisy. That's not how you spell noisy. What the fuck? Function get noise and self and string.
In other words, functions and methods that a struct must implement if it wants to have that trait. The noisy trait specifies that the struct must have a method named getNoise that returns a borrowed string slice if the struct wants to be noisy. So let's add an implementation of the noisy trait for Red Fox.
Implement noisy for red fox. Get noise and self string meow. What? Why are you saying meow? It's a fucking fox.
Let's take a look at how this works. We implement the noisy trait for the Red Fox struct, and our implementation of the required getNoise method is meow, which is all great, but why
Wow.
bother? We could have just implemented that method for Red Fox directly without involving a trait at all. The answer is that once we have a trait involved, we can start writing generic functions that accept any value that implements the trait. This function takes an
Hang on.
that once we have a trait involved, we can start writing generic functions that accept any value that
What the fuck is that? Function print noise. T noisy item T. Oh my fucking god. Okay. Item dot get noise. You're fucking shitting me. Oh.
implements the trait.
Hang on, my
This
wife's
function
texting me.
takes an item of type T, which is defined to be anything that implements the noisy trait. The function can use any behavior on item that the noisy trait defines. So now we have a generic function that can take any type as long as it satisfies the noisy trait. That's pretty cool. As long as one of either the trait or the struct is defined in your project, you can implement any trait for any struct. That means you can implement your traits on any types from anywhere, including built-ins or types you import from some other package. And on your structs, you can implement any trait, whether built-in or from some project.
Oh my.
Here I've implemented the noisy trait for the built-in type U8, which is a byte. So our generic print noise function works just fine with byte.
Okay, so then we can do let noisy for U8. Function get noise and self and string byte. Then we can do print noise 5U8. What the fuck? That's so stupid.
There's a special trait called copy.
Oh
If
my
your type
god.
implements copy, then it will be copied instead of moved in move situations. This makes sense for small values that fit entirely on the stack, which is why the simple primitive types like integers, floats, and booleans implement copy. If a type uses the heap at all, then it cannot implement copy. You can
Okay.
opt in to implementing copy with your own type if your type only uses other copy types. Okay, let's go through an example of where traits really seem to shine. Let's say we have a game with a goose, a pegasus, and a horse. These
Okay.
have several attributes in common. These two can fly, these two can be ridden, and these two explode.
What
You
the
can
fuck?
see how it could get really tricky to use object inheritance to define the correct behavior that each final object needs to have. But it's pretty straightforward with traits. The
Okay.
goose implements the fly and explode traits, the pegasus implements the fly and ride traits, and the horse implements the ride and explode traits. And we're all happy. It's interesting to note that traits implement inheritance, so a trait can inherit from another
So this is like a fucking class.
trait. That makes it possible to have a trait inheritance
It's like an
hierarchy
E.
like
So
this,
it's
where
like an enum in fucking C or a class in any other language.
movement is the root trait. Run inherits from movement, and so on. Let's say we have a separate damage trait hierarchy with a damage parent trait and an explode child trait. Then a horse struct that implements ride and explode also has to implement the parent traits movement, run, and damage. Making your trait inherit from a parent trait really just means that anyone who implements your trait is going to have to implement the parent traits as well.
Okay.
Traits can also have default behaviors.
Oh my
So if you
god.
design structs and
Of
traits
course they
carefully
fucking
enough,
can.
you might not have to implement some of the trait methods at all. If you want to implement default trait behavior inside your trait definition, instead of ending your function or method definition with a semicolon, add a block with your default behavior. Then, when you implement
Add
the
a
trait
block with your default behavior. So trait noisy. Okay. Function getting loud and self print line shut the fuck up. So that's a default behavior, right?
for your struct, just don't provide a new definition for the method whose default implementation you want to use. The presence of an implementation
No, that's wrong.
will override the default. This is a fully
Oh wait. Okay, so then if I wanted to do implement run noisy for, let's make a new struct test stuff u32 stuff2 string. Okay, so we're going noisy for test would be that. Then print noise, let's do then function is noise t test item t. Okay, line item dot getting loud. Then if I go down here, let's do 5 u8 anyways.
example, the robot struct in the
Whatever.
middle implements the run trait, but it doesn't override the default
That's
run
wrong.
method. So when robot.run is called from main at the bottom, it executes the default run method defined on the trait at the top and prints, I'm running. One gotcha I really ought to mention. You can't define fields as part of traits.
What
That
the
may be
fuck?
added in the future if someone can figure out the right way to do it. In the meantime, the workaround is to define setter and getter methods in your trait. In the next video, we will go over some of the collections in the standard library.
Okay. Exercise abstracts and traits. Alright, here comes the hard part. Okay, it's getting there. Exercise F, source main. Okay, define a trait named byte. Okay. Hold on. Single required method function by itself and myself. Trait byte. Trait byte. Function byte. Byte. Okay. Well, we will call this method when we want to byte something. Cargo run. Yep, cool. Okay, now create a struct named grapes. Struct grapes. You can actually just do mut self. Can you? It doesn't need to be capitalized. Oops. Here. It needs to be capitalized. No, without self. Oh. So like that. Cool. Sounds cool. Okay. Struct grapes. Now create a struct named grapes with a field that tracks how many grapes are left. If you need a hint, look at how it was done for carrot at the bottom of this file. You should probably use a different field. Right above the struct definition. Derive debug. Percent left F32. If you need a hint, struct grapes left F32. Okay. Implement byte for grapes. When you byte a grape, implement byte for grapes. Subtract 1. So implement byte from grapes. Carrot function byte self and itself. Function byte. You can do that, right? That's what you're talking about. Self instances. Gotcha. Okay. Let's do grapes left minus equals 1. Okay, this should run without any. Do you finish number one? This should work. Okay. Challenge. Okay. Let's see. And carrot the correct def. It doesn't say anything about carrot. Define a trait named byte. Okay. Trait's done. Okay. Trait byte. Struct grapes. Struct grapes. Implement byte for grapes. Function byte. Right? Grapes. Let's clear that real quick. Okay, expected, found. Let's just do this real quick. Hang on. Errors. Function byte. Clear. Run care. Struck grapes. Grapes equals. Oh, amount left. What's amount left? Expected F32. There we go. I got it. So let's go back through this real quick. So I can just do and myself on all these, right? And it should do the same thing. No. I'm just gonna leave it because I don't know what the fuck you're talking about. So, but lowercase s on self. Okay, so do and myself. That should still work. And then, where is it? And myself. Gotcha. So instance, like that. Yeah. Okay, I got you. Okay, well that was easy. I get it. Cool. Nice. What is this? I suck that's based on capitalization. I mean, it makes sense. It's the same as anything else. Like, in fucking Python. Oh, hang on. You can't do true. It has to be true. You can't do false. It has to be false or 1. Or, wait, when it goes true. I mean, it's kind of makes sense, you know? I guess. I don't know. It's something. Yeah, that's fair. But you can, like, implement false as false and shit. So I get what you're talking about. But this is cool. I kind of like Rust. I think it's really cool. It's definitely something to learn. Hey, we're almost done. We have 1, 2, 3 left. Damn. Didn't we already do variables? Yeah. Okay. So this is kind of cool. Then we got like 6 more fucking.
Exercise F. Structs and traits.
Okay, let's just go through and see
As always,
what he
I
says.
encourage you to go give this exercise a try yourself. If you are going to
Just wait until you try to look inside a compiled binary. I can already do that if I want to. Here. Let's open that with I'm Hex real quick. Hey dear, what's up? I'm almost done. Yes. Oh no. Oh shit, okay. Oh, what the fuck? Oh yeah, I don't like this at all. Rust panic. But you have like indicators that it's rust. So that's kind of cool, I guess. Jesus. Yeah, it's definitely something. I like that it has indicators though. You can determine if it's rust or not. That's cool. But Jesus. Let me finish this course part and then we can go. Okay.
To do that, now is the time to pause.
I already did it, sir. Let's continue.
Number 1, define a trait named bite. Okay.
Done.
Trait named bite. Define a single required method. Function bite, which takes a self, which is a mutable reference to myself. And that's all we need in the trait. We will call this method when we want to bite something.
Mm-hmm.
Once this trait is defined,
This is
you
correct.
should be able to run the program with
Except for your little
any errors.
thing wasn't added.
Alright, I take a bite. Carrot is now % left 80. Number 2. Now create a struct named grapes with a field that tracks how many grapes are left. If you need a hint, look at how it was done for carrot at the bottom of this file. This is going to make it so that it can be printed out. We're just going to derive the debug trait for us.
Mm-hmm.
Our struct grapes, a field that tracks how many grapes are left. Well, let's just call it amount left. And what is it? How about I-32?
This is
If we run
correct.
this, nothing's going to happen except for it shouldn't crash. So let's make sure it doesn't crash. Did not crash. Great. Implement bite for grapes. Okay.
Okay.
Simple bite for grapes. When you bite a grapes, subtract 1 from how many grapes are left. Okay. So we need that function bite there. So let's copy and paste that. So we've got a mutable reference to ourself. We know that we've got an amount left. So let's say self amount left minus equals 1.
This is right.
Don't have anything to return, so we're all done.
We're good.
Into main. All right, number 4.
Okay, let's try to do this one real quick. Uncommon code will create a generic bunny nibbles function that takes a mutable reference to any type that implements bite. Yeah, I'm not doing that.
Uncomment and adjust the code below to match how you defined your grapes struct. Okay, amount left, we're good there. So we're going to create a grapes with 100 grapes. Then we're going to grapes.bite, and we should see eat a grape, and it should show our grape representation here with 99. Save, clear, cargo run. Okay,
Boom.
great,
Problem solved.
99. Good stuff. Last, we have the challenge, which I will leave up to you.
I don't want to do the challenge. Okay, that's it. We're good. Alright, so we're going to fucking end that stream here today. I appreciate y'all coming and watching. And we will pick it back up tomorrow. Have a good day, guys. Bye.